Okay. 3, 9, 3, 11, 3, 10. That's the order we did stuff in. So 3, 9 was secant, cosecant, tangent. No, 3, 9 was inverses. 3, 9 inverses, 3, 11. 3, 7, is that right? When did we do tangent graphs? Was that 3, 11? Yeah. Tangent, cosecant, that was all together? Okay. 3, and then 3, 10 was solving. Solving's the big thing. So your test, whenever that is, right? The biggest thing about secant, cosecant, and tangent and cotangent is where are the asymptotes? Those will be your questions on the test. Maybe the range, maybe the domain, but the domain is the asymptotes, right? It's everything but the asymptotes. So that would be the domain for any one of those. The range would be everything that sine and cosine is not. It's their domain. Anyway, those type of, you won't have to graph one. You will not have to graph one. You just got to know what the graph looks like. Inverses, I think, are pretty difficult, truth be told. They're not that difficult with our homework, but the test questions are difficult. So when we get to those questions, make sure when we get to AP questions on those, make sure you focus on that. And then solving. And solving, some of them I think are pretty easy, and some of them are really difficult. Inequalities are a whole lot more difficult than equations. Because equations, you don't have to test anything. You just got to solve it and find it. Inequalities, you got to find it and then test points, right? Okay, so just kind of keep all that in perspective of where we're at and what we got going on. We're getting close to getting done. Questions over part D. Any question? I mean, most of you guys finished, I think, in class, or you worked hard on them in class. You can solve these with the circles. I had got this question for quite a few times. You can solve them with the circle, figuring out where it is, or you can solve them with a sign chart. Some of them you almost have to use a sign chart because you don't know, it's not just a single step, right? It's not just if it's just a single cosine or sine, you can use the circle. But if you have 2 sines or 2 cosines or a tangent or something like that, you almost have to use a sign chart. Sign charts always work. So that's why they had those. And then they went to the other equations, inequalities. Yay? Anything? Any of those we got to do? Quiz Monday. Another quiz Monday. Some of you guys came in and took your retest for 8, 9, and 11. So remember, you got those if you need to. Okay, we're good? Ready for 12? I got 2 12s. Does yours look like, start looking like that? Does it start looking like that? All right. Equivalent representation of trigonomic functions. We call them trig identities. Trig identities. Most of these you know already. In this section, we're going to explore several ways to write equivalent representation of trigonomic functions. Thanks. Good morning. Equivalent representations of trigonomic functions. We already have several tools in our math box that we can use to write trigonomic functions in different forms. And so that first group are the ones that you know already, okay? You know these already. You know that sine is 1 over cosecant. Hope, my guess is, oh, there. And you also know the opposite of that, or the reciprocal of that, that cosecant is 1 over sine. So these can be written either way. Sine is equal to 1 over cosecant. Sometimes you might 1 over cosecant rather than you would want sine, or vice versa. Sometimes you might want 1 over sine rather than cosecant. Typically, we like this one better than this one because we kind of somewhat at least understand sine, cosine, tangent more than we do secant, cosecant, cotangent. And truthfully, I'm not sure how much we understand tangent more than we understand it's sine over cosine. Cosine is 1 over secant, or secant is 1 over cosine. Again, those are the ones you already know, the reciprocal functions. Tangent can be two different ones. It can be 1 over cotangent, or it can be sine over cosine, either one of those. And then cotangent's 1 over tangent, or cosine over sine, either one of those. So those 6, 2, 4, 6, you already know, okay? So those are trig identities, and the reason why they're identities is because they're equivalent ways of writing the same thing. This equals this. Just like sine of pi over 2 equals 1. This equals this, okay? These identities allow us to manipulate trigonomic expressions and rewrite these expressions in equivalent form using various trigonomic functions. So, we're going to look at example number 1. Example number 1. I've got f of x, which is y. I've got a sine. I've got a secant squared x, and I got a cosecant. So I have just thrown a bunch of trigonomic functions up there. And basically, they're going to just tell you to simplify this thing. Or rewrite it. Or rewrite is what they're going to say. Which means rewrite it basically means simplify it. Okay? So we are going to simplify that. It doesn't look that difficult right now, but we want to simplify it. So anytime we simplify things, guys, my suggestion to you is change things into sines and cosines. Change to sines and cosines and see where it goes from there. You don't have to do it like that, but that's just my suggestion to try to get things started. Okay? What makes these difficult is there are so many different ways to do it. Make sure I fix your attendance, please, when we leave. Fix your attendance. Same thing, Eve, when we leave. Let me make sure I fix your attendance. So, in this particular one, in example number 1 here, I've got sine on top. So I'm going to leave that sine. And I'm going to change secant squared to 1 over cosine squared. Or I'm going to put cosine squared down here at the bottom. Either way. I have a bad habit of dropping variables. Don't drop variables. I've got a huge habit of dropping variables. So y'all catch me on that when I do it, right? And I just did it right there. I just put sine. I didn't put the variable with it. So I'm going to put secant squared basically on the bottom and not make it secant squared anymore. I'm going to make it cosine squared because secant squared is 1 over cosine squared. So I'm going to do, I might even do cosine x, cosine x. You can do cosine squared x. I'll do cosine x, cosine x. I'm just kind of seeing where this is going, guys. I really don't know. I don't know where this is going. I just know they want me to rewrite it. So I'm in the process of rewriting this. I got a cosecant on the bottom. And a cosecant on the bottom means I basically can put that on top and make it a sine, because cosecant is 1 over sine. And if it's on bottom and it's 1 over sine, that's basically a flipping and a multiplying. If it's already on bottom, I can put it on top. If it's on top, I can put it on bottom, just with the reciprocals. So that would put a sine up here. Rewrite it as an expression. Oh, I didn't read the rest of this. I'm sorry. Rewrite it as an expansion of tangent. Well, that's kind of nice because I got sine and a sine, which is sine squared. I got a cosine and a cosine, which is a cosine squared. Or I've got a sine over a cosine, which we know is tangent. And I got a sine over a cosine, which I know is tangent. And so this whole thing here becomes a tangent, and this whole thing becomes a tangent. And if I got a tangent and I multiply it by a tangent, I'm going to end up with a tangent squared. Hopefully you guys kind of see where we're going with this and what they led me to believe of where I'm going to end up with this. They're basically telling you how they want this to end up looking. And so that's me by doing this. It just so happens I could have left it right here. I don't know if that's simpler or I rewrote it. They told me to rewrite it, so I did. But they told me to rewrite it in terms of tangent, and I don't have terms of tangent, but I basically do. This ends up being a tangent x, and this ends up being a tangent x. And technically that's right, but you guys are too smart for that, and you guys know that we can combine that and make it look even a little bit nicer. And I would basically have tangent squared x. I've taught you guys, or I haven't mentioned a couple of times that I don't know if you really want to circle your answers, but I would just keep kind of going down. So I started off with this. Ooh, I probably should say equals f of x. They do say an expression, so I think we're okay by leaving that off. It doesn't say by an equation, but you should. And then it kind of even lets you on, and no other trigonomic functions. So basically, I got to end up with tangent and nothing else. I can't have any secants. I can't have any cosecants. I can't have any tangent, or cotangents. I can't have any sines. I can't even I can't have anything else. I was going to have tangents. And so that worked out pretty nice. Question about that? We got the second one. Some of you guys have already started this. Let g of x equal cosecant and tangent, and rewrite it involving secant and no other trigonomic functions. I don't have a single secant up there right now, but I'm just going to see what happens, right? So cosecant, I'm going to change that. The best way to do these is change them to sines and cosines. It's the best way. So cosecant, I'm going to put 1 sine. Tangent, sine over cosine. Who can tell me where I think I can go from here? What can we see? Hit me. You got a sine x over a sine x? Anything over itself is always a 1. You got common factors. You got a 2 over a 2, whatever you want to say. They divide out, they cancel, whatever you guys want to say on that. And so once the sines go away, I'm left with 1 over cosine. I have rewritten it to start with, but they want it rewritten in secants. Well, that's really, really nice that they want secant, because 1 over cosine is secant x. My board is jumping this morning. I got to write a little bit slower, I think. What do you guys think? Yes, no, somewhat, maybe? This is just a start. They don't get as easy, but I mean, if you can you're rewriting it. How do I know what to do? I don't know where to start. I just kind of start going. Just write down something that's not wrong. Don't change cosecant to tangent. That doesn't make any sense. Okay. They're proving all this stuff. I don't care about proving it. This is what you have to know. Sine squared Sine squared plus cosine squared is 1. These are called the Pythagorean identities. When we get done, we're going to have, don't quote me, 8 identities, 12 identities, 8, 6, 7, 8, 9, 10, 11, 12 identities, I don't know. When I taught pre-cal, we had to have, I think there were 20 identities we had to know. You know 6 of them already. What you got, Charlie? You bet. You know 6 of them already, those first 6. This is the 7th one. Sine squared plus cosine squared is 1. And just, the way I kind of remember, I mean, I don't think this one's that, you'll know this one by the end. I don't think it's that hard. But you guys remember the unit circle, right? And the unit circle, then the equation for a circle is x squared plus y squared equals r squared, yes? Right, that's the equation for a circle. Well, x, you know, goes with cosine, and y, you know, goes with sine. And so for some reason, I don't know why they put sine first instead of cosine, but it doesn't matter because it's addition, and addition is commutative. You can do sine squared plus cosine squared or cosine squared plus sine squared either way, and you get the same thing. So sine squared, cosine squared equals 1. That is an identity that you will use a bunch. And you just got to know it because it's not on your formula sheet. Just like you have to know that cosine is 1 over secant. And you have to know that tangent sine over cosine or 1 over tangent or whatever, or 1 over cotangent. You have to know these. Now, there's 2 more over there. They are derived from this one. I don't ever have these memorized, truth be told. I always forget them. Every year I forget them. Now, by the end of the semester, I'll have them memorized again, but you can get those from this one. So let me show you really quickly, because it may happen on the test where you sit there and go, I don't know if I remember those 2 or not. So I'm going to go with sine squared. Let me abbreviate just a little bit. Sine squared plus cosine squared equals 1. Y'all go ahead and just kind of with me on that. I'm going to divide everything by sine. Divide everything by sine squared. I'm getting ready to divide everything by cosine squared also. So if I divide everything by sine squared, okay, y'all with me? Again, this is non-mathematical, but hopefully you can follow this. I don't have a whole lot of room over here. Sine squared over sine squared is 1. Cosine squared over sine squared is cotangent squared. And 1 over sine squared, sine, cosine, is cosecant squared. Y'all okay? That's that last one over there. So the next 2 get derived from this one. If I divide everything by cosine squared, oh, that's what I did. Sorry. If I divide everything by cosine squared, I'm going to end up with this one. If you divide everything by sine squared, you're going to end up with that one. And so, again, to this day, however many years of mathematics I've done, I have this one memorized. I got that one memorized. The other 2, I don't. But I can get the other 2 pretty quickly off of this one. And after you guys do it quite a bit, my guess is most of you will have that memorized. Just like I don't have the thirds memorized, but I got them by the 6th. And I'm going to bet that's the way you guys started off, but eventually you guys now have the thirds and you don't have to go all the way by the 6th. After we do this for a couple of weeks, you won't have to get those. But if you forget on a test, you got enough time to be able to find it. Those are called the Pythagorean identities because they're coming from the triangle. They're coming from the x squared plus y squared is equal to z squared. That's how it's derived. x squared, which is sine, or cosine, I'm sorry, y squared, which is cosine, and then z squared, which is the radius, which is always 1. So sine squared plus cosine squared equals 1, 1 plus tangent squared equals secant squared, and 1 plus cotangent squared equals cosecant squared, which that's kind of nice because the cos do go together on this one. 1 plus cotangent squared equals cosecant squared. But sometimes students go, I don't remember if it's cosecant squared equals cotangent squared, or I'm telling you that I think the best way is to memorize this one and get the other two from this. And it just takes this right here to do it. 1 cotangent cosecant. Tangent 1 secant. I'm letting that soak in. Pythagorean identities. And again, you just got to have these memorized. You got to have them memorized. There's no other way. This one I think is easy to memorize, and those two are really easy to derive from this. Those 6 you already know. I hope. So there's 6, 7, 8, 9. Those are 9 identities you have to know. Like I said, we'll add some more to it, but those are 9 you got to know. Question so far. Everybody okay? All right. I deviated from what I was supposed to do. So let me take control. It's not. Okay. I'm not teaching those. No. No. We haven't yet. Let's bounce down to example number 3. Bounce down to example number 3. I got f of x is equal to tangent x over cosecant. Rewrite it as a fraction involving powers of cosine x and no other trigonomic function. I don't need the Pythagorean identities for this. I don't think. Maybe I do. I don't know. Tangent x. I'm going to make it sine x over cosine x. And then cosecant, I'm going to make as 1 over sine. Okay. Hopefully you guys have seen fractions over fractions enough. You should be really comfortable with that by now, and I don't know how much of that you've had up until this class. But anytime you have a fraction over a fraction, that's like a fraction divided by a fraction. And you know when you take a fraction and you divide it by a fraction, you actually take this fraction and multiply it by its reciprocal. Oh, I think I remember doing that in 3rd grade. Fraction divided by a fraction is a fraction times a reciprocal. You always flip it. And so this sign is going to go up here with this sign, and this 1 is going to go down here with that cosine. And I don't really flip and multiply other than the fact that I just flip it at the same time. You gotta start, if you haven't yet, with the sine over the cosine stuff, you should get really comfortable with fractions over fractions. And so this now ends up being sine squared over cosine. And now I'm stuck because I don't know what to change sine into other than maybe cosecant, but I don't want to do that. And I don't know what to change cosine to other than secant, and I don't want to do that because it tells me I want everything in terms of cosine. I want everything in terms of cosine. And it says powers, so I'm okay with powers, but I got to have everything in cosine. And right now I don't. I got a sine squared and I got a cosine. And I could make this, let me just side note for just a little bit. You don't write this down, just kind of follow. I could make this sine, I know I dropped the x's, cosine. Y'all with me on that, right? And sine over cosine is tangent. So I could make it that. I could. There's nothing wrong with that, except they want everything in terms of cosine, so that doesn't help me any. But I could do this, and sometimes that might be the right move. This particular time it's not, because, again, that's what makes these hard. Your job is to get what they want. Turn it into what they want. And so you got to manipulate this thing to try to do that, okay? Now, we just learned 3 Pythagorean identities. And you will use those a bunch, and you just this is starting to see things mathematical, and it's not the easiest thing in the world. It's not. But you just learned just a second ago that sine squared plus cosine squared is equal to 1. And so I'm going to write that over here. You may need to do that, but you know that sine, and again, I'm going to cheat. Sine squared plus cosine squared equals 1. I know that's not mathematically correct, but I'm just using that as, I'm getting ready to use that for my answer because it wants everything in terms of cosine squared. And if I know that sine squared plus cosine squared equal to 1, then I know that sine squared is equal to 1 minus cosine squared. Just by a simple rearranging that function, moving the sine to the other side, subtracting cosine from both sides. If I subtract cosine squared here, and I have to subtract cosine squared here, then I'm left with sine squared is equal to 1 minus cosine squared. And so that's what I'm going to replace sine squared with. I'm going to replace this sine squared, oh, y'all didn't tell me I dropped the x there. I didn't mean to drop that x. Told you, I got a bad habit of doing that. Try not to do that. For sure in your final answer. If you don't have it in your final answer, you're going to be counted wrong. If you drop it somewhere in here, sometimes you're okay. So I'm going to change that sine squared into 1 minus cosine squared. And I think I'm done. I have done what they asked me to do. Are there other ways I can do this? Yes. There are other ways I can do this. I could make this 1 over cosine minus cosine squared over cosine. I could. I could split that up into 2 separate fractions. but I don't think that helps me any. It's still in terms of cosine. If I make it 1 over cosine, I could change that to secant, but then I don't have things in cosines. Yes, ma'am. Oh, man, you can, if you want it wrong and get your head chopped off. But that is a very, very common mess up from students. Okay, so let me side note that over there. That's a great, if it's not the most common I see from students, and the only reason why I know that is because I did it when I was students, right? But it's just very, very, very common is to cancel that cosine with that cosine, and you can't because this cosine squared is not a factor. You can only cancel out factors, right? So a side note, this has nothing to do with sines and cosines. This is mathematics. Where's my blank white screen? I need this. Please. Well, I didn't have to go through that whole deal. So, side note, this mathematics. X plus 2 over 2. I'll see that. That's not right. You can't cancel that out. That's not a factor. If it was 2 times x plus 2 over 2, I can cancel those because those are factors, right? So when I have 1 minus x squared, now this is not that common. That's common. That's common, which is almost the same move as that one, and that one's not very intelligent. This one's is equally not as intelligent, but this is a very, very common You can't cancel this x with that x squared because this x squared is not a factor. It's being subtracted from 1. Okay? I'm so glad you asked that because I forget that I need to emphasize those things because I'll see that a lot. Yeah, you can't cancel out unless they are factors. Alert. Oh, there it goes. About that time. All right, go back here. I'm done with that. That's an acceptable answer. There are other acceptable answers. 1 over cosine x minus cosine squared x over cosine x. Now, this one on the right-hand side, I can cancel a cosine out if I wanted to. If I wanted to. You can cancel that one out because they're factors now. That kind of goes back to your old slope-intercept stuff, right? When you just used to divide it by 2, and then you had to make it 1/2 x minus 4. You couldn't make it x minus 2 or 4 or whatever. That's an acceptable answer. And then canceling the cosines out is acceptable answer. Which one's right? They're all right. You did what they asked you to do. When I get to what they asked me to do, I'm stopping. I'm stopping. Don't go further because if you go further and mess up, they're going to count you wrong. What if I don't go far enough? If you did what they asked you to do, you went far enough. Soaking up? So I would leave it just like that. Now, if it's multiple choice, you may not see that answer. You might see this, or you might see something else. But they will no way in the world are they going to give you both choices. No way they're going to give you both choices. So if it's multiple choice and you don't see what you end up with, you got to keep manipulating it until you see one of those 4 answers. Yes, no, somewhat, maybe. Okay. Let me see what the homework is before I give you. We got 2 days for this, and I don't want to give you all the identities. Unless you need them. I can't read. I think so. 12. Tangent, secant, secant, secant. Okay. We're going to call it quits there. I am very, 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 myself, hesitant to give you the trig identities, just like I was very hesitant about giving you the unit circle. Because if you give the unit circle and you look at it and you look at it and you look at it and you look at it, you don't learn it. Fair enough with what I'm saying? So if I give you these trig identities, which I'm going to, I don't really want you looking at it, because I need you to know them. Yay? Because you don't have this on the test. So if you don't have it on the test, it's hard to look at it and not be comfortable with it. But I get it. So I'm going to give it to you. These are all the ones we got to know. So these are the 6 that we do know. These are the identities, the Pythagorean ones, just rewritten 4 different ways. So you already know all these. So we got to learn this one and we got to learn this one. Yay? So anyway, I'm going to give you that. Then I'm going to give you the homework. Everything we don't need the sum and difference and the doubles for the homework. So we'll do those. It's Friday. Friday's A-Day, right? So we'll do those Friday. Friday's B? Okay. Then we'll do them Monday. Quiz Monday too. Yeah. Sorry, I didn't mean to hit you. There was no reason to do that. I didn't hit you. I mean, sorry to drop my papers close to your head. I did not hit. Hump day. Woo woo. Wednesday. Huh? I love it. Especially for my stats kids. They're going to take another test today. It's their last chapter test. You know, don't you? That girl. Poor Paula sees me every day. Sad. I'm not supposed to agree.